Two continents sit just a few miles apart, separated by bright blue water. Why has no permanent road ever connected them? The answer isn't a lack of ideas, it's the challenge beneath the sea. Now, engineers believe the technology finally exists to make it real. A bridge and tunnel link between Africa and Asia could soon turn a long journey into a simple drive. For millions of years, Africa and Asia have been neighbors that never quite touched. The Red Sea has stood between them like a natural border, narrow in some places, deep in others, and always powerful. On a map, the gap looks small. In real life, crossing it takes time, planning, and patience. Right now, ferries carry people and vehicles across parts of the Red Sea. They work, but they are slow, limited by weather, and unable to handle massive traffic. That is why engineers and planners have been studying a bold idea for years: a permanent bridge and tunnel system that would directly connect Africa and Asia for the first time in human history. To understand why this project matters, we need to zoom in on a very specific place called the Strait of Tiran. This narrow passage sits between Egypt's Sinai Peninsula in Africa and Saudi Arabia's Tibuk coast in Asia. On one side, you have rugged desert mountains and resort towns. On the other, quiet sandy hills meet glowing blue water. At its narrowest point, the distance between the two landmasses is only about 8 miles. On a clear day, you can actually see the opposite shore. That short distance is exactly why this location has caught the attention of engineers. Every ship traveling toward the northern Red Sea must pass through this strait, making it one of the most important sea gateways in the region. Now, planners want to add something new to that gateway: a road and rail link stretching between continents. So what are engineers actually planning to build? The idea is a continuous connection between Africa and Asia that could carry cars, buses, and trains. Right now, there is no final decision on whether it will be a bridge, a tunnel, or a smart mix of both. Each option has strengths, and each comes with serious challenges. The biggest problem is hidden underwater. Near the shore, the seabed is shallow and firm enough to support massive pillars. But move farther out, and the ground drops suddenly, almost like stepping off a cliff. In the deepest part of the strait, the water reaches around 900 feet deep. That depth is far beyond what normal bridge pillars can handle safely. Because of this, engineers can't use one single design from start to finish. The structure must change depending on what lies beneath the water. If they choose to build a bridge section, the foundation would rely on enormous steel tubes called caissons. These are lowered to the seafloor like giant metal buckets. Once they are in place, water is pumped out, creating a dry space where workers can pour concrete and build solid pillars. From there, massive cranes would lift and place long road sections between the pillars, connecting them piece by piece. This method works well in shallow water. However, as the depth increases, pressure rises, the ground becomes softer, and waves grow stronger. That makes construction slower, harder, and far more expensive. This is where tunnels become useful. Instead of fighting the deep water, tunnels simply go underneath it. Engineers can use huge tunnel boring machines that slowly grind through rock, or they can build large tunnel sections on land, float them into position, and gently sink them into a prepared trench on the seabed. This method has already been proven. One famous example is the Hong Kong-Zhuhai-Macau link, which combines bridges and underwater tunnels to cross busy shipping lanes in deep water. That project showed the world that hybrid designs can work even in extreme conditions. Even though the open water gap is only 8 miles, the full structure would be much longer. Why? Because roads and train tracks need gentle slopes. You can't just drop cars straight into a tunnel or send trains down steep angles. The ramps leading up to and down from the crossing must be long and smooth. When those ramps are added on both sides, the total length could reach nearly 20 miles. That puts this project in the same league as some of the largest crossings ever built, including the Chesapeake Bay Bridge Tunnel in the United States and the King Fahd Causeway between Saudi Arabia and Bahrain. But size isn't the only challenge. The Red Sea region is extremely hot. Temperatures often rise above 100 degrees Fahrenheit. In that heat, concrete dries too quickly, which can weaken it if not carefully controlled. Engineers would need cooling methods and limited work hours to make sure the material sets properly. Steel also expands in high temperatures. Even small changes in size can cause problems when you are trying to align massive pieces with perfect precision. On top of that, workers cannot stay under direct sunlight for long without risking serious health issues. Then there is the salt. Salty sea air is harsh on metal. It speeds up rust and corrosion, which means every part of the structure must be protected with special coatings and checked regularly. Without constant maintenance, even the strongest materials would slowly wear down. If construction begins, the timeline would stretch over several years. A useful comparison is the Öresund link between Denmark and Sweden. That project is about 10 miles long and took around 4 years to complete in much cooler and calmer conditions. Building across the Red Sea would likely take longer due to heat, depth, and environmental limits. The cost is another major factor. Early estimates suggest around $4 billion, but large projects often grow more expensive as challenges appear. Unexpected ground conditions, design changes, and environmental protections can all raise the final price. Speaking of the environment, this might be the most sensitive part of the entire plan. The Strait of Tiran is home to dolphins, sea turtles, rays, and several species of sharks, including gentle reef sharks. Below the surface lies one of the most beautiful coral reef systems in the Red Sea. These reefs are not just colorful, they are valuable. Scientists have found that some corals in the northern Red Sea can survive higher water temperatures than many others around the world. That makes them incredibly important for studying how marine life might adapt to climate change. Because corals grow slowly, even small mistakes can cause lasting damage. Cloudy water filled with sediment can block sunlight and smother coral. Loud noise from drilling can disturb marine animals. Increased ship traffic can change how sea life moves and feeds. To reduce these risks, engineers would need to take extreme care. Construction zones could be surrounded by silt curtains to keep sediment from spreading. Heavy machinery would need to avoid areas with dense coral growth. In some sections, tunnels might be chosen instead of bridge pillars to leave the seabed untouched. Marine scientists would monitor water clarity, noise levels, and animal behavior throughout the project. If signs of damage appear, work would need to slow down or change methods. Protecting the ecosystem would not be optional. It would be essential. If everything is done correctly, the rewards could be enormous. Today, traveling by land between Africa and Asia is a long, winding journey. Drivers must go all the way around the top of the Red Sea, passing through multiple countries on a trip that can exceed 1,000 miles, just to cross a gap that is only a few miles wide. A direct link would change that completely. Travel times would drop. Trade routes would become faster and cheaper. Ports on both sides would gain easier access to new markets. A drive between continents would feel as normal as crossing a long highway bridge. Tourism would also benefit. Short trips between regions would become easier. Resorts would attract more visitors. For many people, crossing from Africa to Asia in one smooth journey would become a bucket list experience. Trains could make it even simpler. Passengers could sit comfortably as the train glides toward the crossing, slips quietly beneath the sea, and emerges on another continent, all in one continuous ride. No waiting for ferries, no weather delays, just steady movement forward. In the end, this project is about more than concrete and steel. If this idea captured your interest, make sure to hit the like button and subscribe for more fascinating stories about engineering and the world around us. See you in the next one.